Okay, so it wants us to express the number of passengers per month as a function of the ticket price. So the number of passengers is N, and it essentially wants us to write an equation for that. So N equals something based on the ticket price, X. So the number of passengers currently is 6,000. Are you with me there? But that's going to change. How? Increase or decrease based on the way they worded this. It's going to decrease. By how much? 100. How many times is the big question? X is the ticket price. So if the ticket price is $200, is it really going to decrease by 100 200 times? No. So let me give you a hypothetical. Let's say the ticket price was $201. How many times would we lose the 100 passengers? One time. Because that's only $1 over 200. Do you follow? If it was $202, you would lose 100 passengers twice, right? So you're going to lose 100 passengers for every dollar amount that this is over 200, which means you take the ticket price, whatever it is, 202, and subtract 200 from it to find out that it's $2 over, and you're going to lose that 100 passengers twice. Does that make sense? So you're taking your ticket price and you're subtracting 200. So just so you can kind of follow this, this is your ticket price minus 200, which will give you the number of times you lose 100 passengers. So I am going to clean that up. That's going to be N equals 6,000 minus 100x plus 100 times 200 is 20,000, right? So 6,000 plus 20,000 is going to be 26,000 minus 100x when that's all said and done. That's your number of passengers based on ticket price. Any questions on that? Am I right? 100 times 200 is 2 with 4 zeros. Okay. So, any questions on part A? Takes a while mainly to come up with this part. Because I think, Andrew, your gut, which was just minus 100x, is people's gut. But that'd be losing. That would be if x stood for the number of dollars it was over 200. That would work. But x standing for the ticket price, you have to do a quick little subtraction of 200 to see how much overage you are to figure that out. Then part B asks the next question is expressing the revenue. So generally speaking, if you're an airline selling tickets and you're filling a plane, how do you figure out how much money you bring in? Loosely speaking. Well, let's pretend. Well, let's start with the beginning scenario. If you had 6,000 passengers, each paying $200, how would you find out the amount of revenue? Just multiplying. 6,000 people, each paying 200, 6,000 times 200. So you're taking your number of passengers and you're multiplying it by ticket price, essentially, right? Your number of passengers, we just spent part A coming up with what that is. The number of passengers is this N expression, which is 26,000 minus 100x. Your ticket price is what? Nope. Well, currently it is. What's that? This, now don't overthink this one. They already told you your ticket price is just X. Nope, just X. Your ticket price is X. Here, we weren't looking for our ticket price. We were looking for how much over 200 we were. See the difference? So times the ticket price is just X, and that's your revenue. So the harder part is definitely coming up with that number of passengers expression. Your revenue is just taking that expression, your number of passengers, and multiplying it by your ticket price. Do you follow? So if I were, just out of curiosity, to graph this, my y-axis stands for what? Which variable is my y? Revenue, good. And x stands for ticket price. So when I'm setting my window for this, because I'll tell you, if I do zoom 6 and do -10 to 10 and -10 to 10, I'm not going to see anything. Because a ticket price of -10 to +10 doesn't even make any sense. We're talking about plane tickets. We're starting at 200. So a ticket price window that would be appropriate to kind of look in and around would maybe be like $0 to $300. And your revenue, as is, the revenue right now is 120,000. Did I do that right? 6 times 2 is 12 with 5 zeros. Yeah. Your revenue currently is 120,000, and that has to have room, obviously, to go up or go down. So when I do my Y scale, I'm not going to do 120,000. I'm going to go, oh, I'm sorry, it's not 120,000. It's 1.2 million. See, if I went to just 120,000, I wouldn't see anything because it's not high enough. But 1.2 million, maybe I'll go to 2 million just to make sure I leave room. Now I'll see a parabola. So this is like an underrated skill to me in math. In no math class do you explicitly spend 2 or 3 days coming up with windows appropriate for certain scenarios, which is why a lot of times kids will try to graph something and they don't see anything and they get frustrated and they have no idea what to do. And I know you try to like zoom in certain ways, but that doesn't always work. You have to have an understanding of what the x-axis stands for and put numbers that make sense, and what the y-axis stands for and put numbers that make sense. Allie? Yep. I did $0 to $300 for the ticket price and $0 to $2 million for the revenue. So what you'll find is, well, currently they each are paying $200. So if I show you where that is, currently they're charging $200. If they want to maximize their revenue, do they need to charge more or less? Look at where we are. Currently they're charging $200 and they're bringing in $1.2 million. Do they want their ticket price to go up or down in order to maximize revenue? Your gut is saying up only because you're thinking if I charge more. But guess what? Sometimes when you charge too much, no one's paying that. If I charge $3,000 for a Nike t-shirt, no one's buying it. So I'm not going to make anything. So charging more isn't always the answer. If I charge less and I scroll backwards, second trace. I just want to trace it. Why won't my cursor get on the graph? Well, I'm just going to do this. If I charge less, somewhere in the market of like 125, I'm actually going to make more revenue because more people are going to buy and I'm going to fill the flights. Maybe right now there's 6,000 passengers per month, but 4,000 seats are left unfilled. That's not good either. Sometimes it's worth lowering the price per person to get more people. Yes? So they'll do this. Why do you think they can get away with charging $8 a hot dog at Fenway Park? Right, and people will pay it. If, by the way, if they eventually charge $20, if like you went tomorrow and it was $20 a hot dog, right, people would stop buying it. So they find their sweet spot that they can get away with. If you went to like a hot dog stand in downtown Buffalo and it was $8 a hot dog, people would be like, sorry, I'm not buying that. I'm getting something else. So depending on the circumstances, companies have to do this to kind of find the best fit that will maximize the profit. So when they say like a market survey, that's what they're talking about. They play around, they up their price, they see what their results are for a week, and then maybe they had better results, so they up it again until they up it too much and they actually lose money, and then they have to backtrack. So, for those business majors in the room, there you go. Any questions? Oh, by the way, if I wanted to maximize my revenue, obviously I can write the equation that my market survey kind of led me to, and then I can just find the, did I do zeros or maximum? If I really truly want to find it, left bound, you find your vertex anytime you're looking for a maximum, and it would be 130 is the best price, and that'll give you the highest revenue. Okay, so flip to the back. That's a harder example, so I left just that one for today. All those ones yesterday I kind of felt were easier, so we could fit in 4 of them. So from your worksheet, I'm also going to do, as a different example, because this is a tougher one too, is number 16. So just on the back here, just write 16. You're not going to copy the word problem, but you can read it up here. An open box is made from a square piece of cardboard 30 inches on a side by cutting identical squares from the corners and turning up the sides. So you have to be able to sort of visualize this. If you pretended that this was your square piece of cardboard, I know it's a rectangle, forgive me. What they're saying is when they make like these boxes in the factory, they just take these sheets of cardboard and they just cut out congruent squares in each corner, like this, and then they fold up each side into a box. Develop. So you know what they're getting here. Good? Okay. So we're going to try to express the volume of the box as a function of the length of the side cut from a corner. So I would say first, draw a square. They said it was 30 by 30. And you're cutting out these squares that are X by X. So along these dotted lines is kind of where my folds would be. These wouldn't even be there. And so once this turns into a box, my volume is length times width times height. But I want that all in terms of X. So if I call this my length, how long is that? 30 minus 2x. That's the original 30 minus the x that got cut off on both ends. And my width here would be what? 30 minus 2x. And my height, once I fold it up, how tall is it? Just x. And there's your volume written in terms of x. So the next part of this question is to find and interpret V of 2, V of 3, V of 4, V of 5, and V of 6. We'll just do like V of 2 and V of 5 just for fun, because we have to talk about part C. V of 2 would be 30 minus 4, 26, times 26 times 2. I got it for you. Don't move an inch. 1352 would be the volume of that. Cubic inches, maybe. I plugged in 2. 30 minus 2 times 2 is 30 minus 4 is 26. Good. If I do V of 6, that would be 30 minus 12, which is 18. 30 minus 12, 18, times 6, 1944. So we could do that over and over again for all the numbers, but we've done a couple, so we get the point. The better question, the more thought-provoking question would be part C. which is find the domain of the V. So if you go back to this, what are the limitations for how big X can be? Obviously, X could be 2, no problem. X could be 6. What can't X be? Can't be a negative number because you can't cut out a negative size corner. Got it. Can't be 0 because you would have nothing to fold up, right? So X has to be greater than 0. We got that. What would be too big? 30 is for sure too big, but so is 29. Think for a minute, why would 29 be too big? Why would an X value of 29 be too big to cut out? Right, because you have to do it on both sides. Yes? So what would be the max you could do? Not 15. So anything less than 15. 14.9 would look like a funny box. But you're right. 14 would be the highest integer, but you could do 14.5. You just can't do 15, because if you cut 15 out and 15 out, then 30 minus 2 times 15 would be a 0 volume. You wouldn't have a box. You follow? Aren't you glad I did a demonstration? So essentially, X has to be between 0 and 15 would be your domain. And if you wanted to maximize that and actually find what the best X would be to make the most space, you would just plug that into your calculator, search for the vertex. Okay? So that's a totally different kind to be exposed to, and I got one more for you. Open. Nope, that's a thing. You couldn't actually cut out nothing because you wouldn't have a box, and you can't actually cut out 15. I just wanted to maybe look at, 10 is the same. Maybe we don't need to do it. How comfortable do you feel with that number of tickets revenue problem? This is just another example. Why don't I do this? Why don't you just start your homework, because you have to do one of those anyway. So from that worksheet, you have to do 9, 11, 15, and 17. You need it? Oh, yeah. Who else was out yesterday? I have these for you. So go through your worksheet and circle or square whatever you didn't do yesterday. 9, 11, 15, and 17. Well, don't do that again. Don't do them on the sheet. There's not enough room. And you want these for practice. So 37 comes from a different sheet that I'm handing you. And don't do it on this sheet either, because we're going to use this again tomorrow. 37 is just one of those investment ones that we did yesterday in class, so it's not. But keep both of these, because we're going to use these both again tomorrow. How about I talk about it? Take it. Now I'm going to do it. That's where 37 is going to come from, Brock.